Okay, I've always loved the vibes of this math paper, and I want to go through part of it. So it's from the late 70s, I think 1978, and it's about prime numbers, which are pretty basic but extremely mysterious. And the author, who's Don Zagier, like he tells the whole thing like a story, and this is, I think, based off of a lecture that he gave. And like he starts with a definition, like a prime number is a number that's only factors are itself in one. You can't break it up into a product of two whole numbers. And then he goes on and just says like all the different ways you could define it. Like if you were an algebraic geometer, you could say a point in spec Z, like that's the way I learned it when I was in grad school. Or if you're a logician, like there's this crazy thing here where the positive values of this polynomial, which has 26 variables, which is the same as the letters in the alphabet. Like the only positive numbers that this will ever spit out if you plug in 26 numbers, A, B, C, D through Z, those are exactly the prime numbers. Like this is crazy. But the paper really starts to get good right here on the second column where he says that prime numbers grow like weeds among the natural numbers. They seem to obey no other law other than that of chance, and nobody can predict where the next one will sprout. The second fact is even more astonishing, for it states that just the opposite, that the prime numbers exhibit stunning regularity, that there are laws governing their behavior, and that they obey these laws with almost military precision. Like what a story, like who wouldn't sign up for this movie? And he illustrates his first point by saying, well, let's look at 100 numbers, from 1 to 100. Here are the primes. There's a bunch of them. But if we take another 100 numbers, so starting at blah, 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 901 to blah, 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 999, we get like fewer prime numbers. And like, how do we know they're like 947? Like, how do we know which ones are going to be prime and which aren't? And if we go just a little bit further, right, this is not that much further along than this. There's 100 numbers in this range and only 2 of them are prime. So that's the part that's like growing like weeds. Like, how can we tell where there's a prime, where there isn't? And it's just so poetic, right? Like these numbers being in the presence of one of the inexplicable secrets of creation, that even mathematicians have not penetrated the secret, is perhaps convincingly shown by the ardor with which they search for bigger and bigger prime. There's a couple detours, but at some point the paper starts to talk about the military precision that the prime numbers have. So if you look, say, up to the number 50, how many primes are there? Well, there you go up on this graph, there's like 15. And if you go up to 100, right, how many primes are there? And if you zoom out, of course it's jumpy because the primes are like weeds, but if you zoom out, the graph looks very, very kind of regular. And in fact, this leads us to look at like, well, how could we approximate it? What is that graph? And it says that the number of primes up to some point x is like x divided by the natural log of x. And so somehow the natural logarithm is relevant in counting prime numbers. Now it gets a little technical. I'm not going to go in the whole paper, but I do encourage you to Google it and read it because there's just all sorts of cool things. So people would like study that approximation and say, well, it's not 100% correct. Like maybe we can make it better. And so people came up with all sorts of different approximations, and you can see how well those approximations hold up as we look at bigger and bigger numbers and look at how many primes there are less than it. Okay, maybe the coolest part of this story, I won't get into exactly what's going on here, but this graph, like, doesn't it look like it's going up? Like, sure, it drops down a little bit, but it generally looks like it's going up. And would you agree, or would you conjecture that, yeah, probably it continues the pattern and surely it's never going to go all the way down to 0? Well, actually, it was proven that at some point it does absolutely go down and get below 0. And when the paper proved that, they proved that this number way down here, that it happens at some point before you get to 10 to the 10 to the 10 to the 34. Oh my gosh, so many fun things. If you have questions for follow-ups, let me know in the comments. This was fun.